Hi, my name is Colby Uncart, and I'm part of Zach Staley and Jack Balmer's group. Our product name is the Stand and Go Walker, and our company name is Uplift Solutions. At the beginning of this project, we had narrowed it down and realized that we wanted to help take people that need assistance or rely on others to help them, and we wanted to make them more independent. So, with that, we strayed into the area of assisted standing. To start off, we created a survey to realize the need for a product like this. Question one: do you or someone that you know have difficulty standing from a seated position? And 75% said yes, that they do know or they have problems standing from a seated position. Question two: what solutions do they use? We know that 60% use another person. Question three: would they be interested in a better solution? Roughly 85% said yes, they would be interested in a better solution. Question four: do they live alone? 80% said no, they do not live alone. Question five: where do they live? 85% said at home. So from this survey, we see that most people that have problems standing from a seated position, they're living at home, they are dependent upon someone else, and they would be interested in a tool or mechanism that would help them be more independent. With this in mind, we created our problem statement based on a 20 survey. 75% of those who are 65 years of age or older or physically impaired and or disabled often need assistance when standing from a seated position. Those who live at home are dependent on someone else's assistance when standing. My part of the project was STEM principles, science, the law of conservation of energy, momentum, and the scientific method were used. Momentum being a very big one in our design. I'll explain later, but our design is a lever. Engineering, we followed the engineering design process. Ergonomics and market research. Ergonomics was a large one, was a large factor in this project because you have to factor in it has to be adjustable for different heights, comfortability, size, weight. You wouldn't want someone lugging around or trying to move something that's too heavy or awkward. Also, into our research comes ADA compliance. If we take a walker and try to change it around, it still has to be able to fit through regular doors, has to be safe in a fire, has to be handicap accessible, wheelchair accessible. The math portion, I will get to that later as I discuss the lever design itself. The first design was a hydraulic piston, and with that comes a two-way switch in and out. Switching in would compress the piston, allowing you to sit down. It kind of comforts you as you sit down. Pressing out would raise the back of the chair, your seat upward and forward, helping you to your feet. Requires a little balance, a little physical strength. My second idea was a winch and pulley system. Like the hydraulic piston, the winch and pulley system, there would be two different sides. Would be mounted to the back of the chair. It would connect to eyelets near the wrist part of the walker, and the cable would attach to the back of the seat. As the winch wound in, it would pull you upward and forward, helping you stand just like the hydraulic piston. But the problem with both of these designs is that they are very costly, they're not machinable, and there's no way to get power to them unless you have some kind of battery pack that would need to be recharged. So we weren't comfortable going this route because it didn't seem very cost effective, and we're doing the same thing with our lever design as with these two designs. So now to move on to the lever design, There is a set of levers on your left, a set of levers on your right. You would place your hands at the front of these levers, and as you would move forward or push down, this horizontal lever would help you go forward, and the vertical lever helps you stand up. So it's bringing your center of gravity up and forward with you as you stand. Back to the math portion. Work, power, efficiency, and the first class lever efficiency was very important in this project. We discovered that by just having one lever, one member that went from the front of the walker to the back, by pushing down on that lever, we didn't have a large range of motion like we wanted. And obviously that was a problem. It used way too much power to get it to move. And with someone that's having problems getting around, we wouldn't want them to have to exert themselves to stand up. They're already having problems. It doesn't fit. So we went with this design, which has two levers. One that helps with vertical, one helps with horizontal motion. We then used stress testing. We placed 500 pounds of pressure throughout the whole unit, and it held up. There wasn't any bending, manipulation of screws or joints. I was very pleased to see how the product held up under stress testing. Made me very confident that it would work in the real world. Onto my reflection. What changes would you make to the design? We have a vertical member here that was meant to be attached to the walker itself, and I didn't get to see how this member would have held up in stress testing over time. I would have liked to see that. That's something I would improve, I would change. I would have a bracketing system for it. Maybe I would have a system where the lever design itself can slip on and off of the walker. That way it can be a walker and the chair. Something to think about. As opposed as what went well and what needs improvement, I was very pleased with the efficiency of our design. It passes all tests. It passes the stress test. What needs improvement? Pinching fingers may be a problem because with moving parts, that's always a hazard. Discuss everything you learned. Wrap up your conclusions to this project. I really take two things away from this project, and that is, with the survey results, marketing is everything for a product. You have to know a targeted consumer. You have to know how much they want to pay. You have to know what features they want. If your product costs too much or it doesn't satisfy the needs of your consumer, you can't sell it. And obviously that's not good. So that really showed me that just because I think something's good or something's going to work doesn't mean that in the real world it's going to sell. And another thing is I would like to draw 3 to 5 designs that I really thought could work and kind of branch off those and see what I can come up with. But this design, I came up with 12 to 15 different sketches, and although some of my sketches I wasn't quite sure about, my teammates Jack and Zach could look at it and say, hey, well, I think you should add this or take this away, and it takes something that seems unpractical to me and it makes a new, unique design that no one's ever seen before. So I thought that was really cool, really innovative. Well, that's all I have for you today. Thank you for watching.